we're playing Universe Sandbox tonight. Most of you are probably very familiar with this game. Anton Petrov, another ASMR artist, A Small Request, which I like, is very fond of this game. There's a Gray Still Plays, a very popular, very entertaining YouTuber. He's done a lot of Universe Sandbox videos, and he is a blast to watch. And interestingly enough, he's clearly from either Miami or somewhere in South Florida, as am I. So I don't know what it is about this game that, what about Florida that makes us attracted to this game. Maybe it's the heat, the unbearable humidity, which he makes very frequent references to. But tonight I wanted to just mess around with the black holes, really have a little bit less of an agenda than I usually do, and we're gonna do some fun things. First of which is to replace the sun with a black hole. We're gonna figure out what happens in that situation. I used to, I guess first things first, we'll have to pause it, and we'll have to annihilate or delete our sun, replace it with a black hole, maybe of equal mass, and then we'll vary the mass from there. So we'll pause it. Now, go get comfortable, whether you're trying to sleep or relax. Look at our sun. And maybe grab a snack, grab a drink. Notice the sun has a trail right here. It's really cool to watch that. Again, I'm fascinated by how accurate the, I guess the engine, the game engine is what it's called, is, how close to reality it actually is, how high fidelity it is to real physics. You notice here that the sun has a tail because in reality the sun it's being pulled, it's being tugged by all the other planets. In this specific simulation, it's just the solar system. Whoa, sorry guys. Yes. So let's go ahead and delete this. But even though the sun is 99% of all the mass in the solar system, how do we delete this? I guess we go tools down here. And there we go. Nice. Even though, wait, can I undo that? No, I cannot. I just deleted the sun. Irrevocably. Cannot revoke that action. But yeah, and I think Jupiter is, well, definitely Jupiter and Saturn combined. They are something along the lines of 99% of all the non-solar matter in the solar system. So, let's see. Okay, so we're going to go here, we're going to add a black hole, and alright, so our sun is deleted. I've selected, let's do, whoa. Alright, we're going to put the Milky Way's supergiant black hole right there. And remember, we're God in this universe, so time is currently standing still. And there we go. And now because this black hole is 4 million times the size of the sun, everything's gonna go in an instant. It's going to be pretty uneventful. There's gonna be one hyper reactive event very quickly, and there will be nothing but the black hole left after that. So I'm going to take this black hole and make it a little bit smaller, make it similar in size to the sun, similar in mass rather. So it's currently 4.3 million suns, which by the way is 1,000 times, less than 1,000 times smaller than the black hole from the M87 galaxy, that the Event Horizon Telescope Array just took a picture of, just to give you some perspective of how large that black hole really is. So this one, we can go all the way down to 1 sun. And look at that, look how small it is now. So remember, we decreased it, and there we go, now we can see it. We decreased it by over 4 million times. So yeah, let's zoom out and press play. And maybe I'll zoom in on the Earth. So it's really cool, and what that guy Gray still plays brought to my attention. I love how he pays attention to the statistics of the Earth when he does, when he manipulates the solar system in certain ways, and he pays attention to the mass as he is adding things, and the temperature as it rises, the appearance, I guess, the climate, yeah, the habitability of it, the atmosphere, surface pressure. Okay, so let's pay attention to I'm going to switch to Fahrenheit because I don't feel like doing math. I feel like being a snobby American using the imperial system. Alright, so let's do it real time. We'll do 1 second per second. Hours per second. Minutes. Seconds. Okay, 1 second. Getting there. 6 seconds per second there. Alright, we'll do 3.5 times speed. We'll just leave it there. Good enough. Press play. And there we go. Now what should happen? In reality, nothing. Sagittarius. So really, nothing should happen in terms of the orbits of the Earth. But certainly, if there's nothing falling into the black hole, no heat should come out of the black hole. There should be no heat created by the black hole. Actually, let's speed it up. That was a ridiculous thing to assume that it would be entertaining to watch in real time. Minutes, let's go fast. Okay, there we go. Whoa. Okay, let's do. Alright, we'll do like 1 day. There we go. Per second. So that's strange. The exact same mass was placed, and maybe it was because I didn't place it exactly where the sun was, but look at that. Mercury's certainly being drawn into it. zoom right into it. Okay. Oh, I'm a dummy. I guess. I forget. Sorry, I'm not used to being God, even though I play this game a lot. So, I guess what I need to do is reload it again, start the simulation. I need to place the black hole before I delete the sun. If I'm really trying to get it right next to the sun. Okay. So, let's pause it. Add the black hole. Whoa, too big. Okay. Weird. Okay. I thought M meant million, but it just means mass. So, we're gonna put it right next to the sun. And really, that's kind of too tempting not to just play this simulation out too, so we already know what to do. Whoa, there we go. Yeah, look at this thing. See, let's look at its stats. Mass is 1 sun, its radius is 3 kilometers, 2.95 kilometers. Surface temperature is negative 273 Celsius, which I'm pretty sure that's absolute zero, right? 0 Kelvin, yeah. So that just means there is no movement of the atoms on its surface temperature. Because I guess atoms don't really exist. They would just be sucked in. Interestingly enough. Negative 460 degrees Fahrenheit. Alright, so let's see what happens. If I okay, we can do 30 times reality. Look at that. It's amazing that the black hole can be 1 solar mass and only 3 kilometers across, when the sun itself is 700,000 kilometers. Okay. Enough useless statistics. Let's hit play. Let me zoom out and see. Get a little better view. Yeah, I guess that's the best perspective. Look at that. And the sun is... the sun is clearly being ripped apart. It's clearly inside the Roche limit, which is the limit at which the tidal forces, wow, are gonna rip it apart like so. Like so. It's weird that, black hole there. Let's check out what the rest of the solar system's doing. I guess it's too short of a time scale to really see far off effects. We're just seeing the sun go off on a really eccentric orbit now. So if I speed that up, so if I put the orbits, actually, let's see what the sun's new orbit looks like. Yeah, look at that. Oh man. So all the planets as well, their orbits got very screwed up. So needless to say, the black hole screws up physics. It just screws up the entire solar system when we just drop a black hole the size of the sun right at the center of the solar system. And let's get rid of the orbits. That's not really informative. Too much so, at least. Let's put the trails there. And let's see how this shakes out if we speed it up. Okay. Alright, so I guess what we witnessed when I first hit play was kind of a slowed down, even though it was sped up. It was like a really close to real time, like a volatile reaction of the sun being probably whipped around the black hole and shot out into space. Like what did the sun do to Jupiter there? Looks like Jupiter doesn't really know who to follow anymore. I feel like that's the beginning of a interesting myth. Jupiter struggles with who to show obedience to, loyalty to, the sun or this new black hole. Alright, so I'm really fascinated with what happens if we reset the situation again, as of course we can do because we're God, and we, instead of keeping the sun, what if we replace the sun? So let's go ahead and put the black hole right next to the sun. It's very convenient that I now know that the black hole with one solar mass is a default component we can add. Okay, so we added that. Go to Tools. Tools and Delete. And there we go. Okay, I'm going to zoom out and oh, you know what? I think that's where I screwed up. Let me see. Okay, so I want to do it stationary, at least because even though the sun is orbiting the Milky Way, this simulation is oversimplified, so it's just going to be a stationary black hole. We're only simulating the solar system right now. I think that's where I'm screwing up. So I'm initializing this simulation with the black hole in motion, which is not exactly what I want to do. Okay, let's try this one more time, and I will initialize this black hole. This black hole, I'll set it here stationarily. Is that a word? I'll make it stationary right here. I forgot to press pause. I forgot to pause it, guys. Sorry, one more time. I'm getting really good at this now. Okay, reload. Or at least I thought I was getting pretty good at it. Maybe I'm not. I guess I'm not. I'm getting worse. Okay, fall asleep to me failing to hit the reload button somehow. This little bugger keeps going away on me. There we go. Okay. Alright, we got it. Only took 10 tries. Not too bad. pause. And we're going to hit play. See how this shakes out. Look at that. Okay. Kind of a success. It's doing relatively what we assumed it would do. Alright. Now, what I want to do, what I'm really curious about, is if Earth gets really cold. And it is. Look at that. Look at that go. Wow. Negative 21 degrees Celsius. Which is, it's probably about the same number in Fahrenheit at that point, right? No, I guess not. Negative 6 degrees Fahrenheit. And it just keeps getting colder. It's just becoming an ice ball. Snowball Earth. Look at that. Australia, Africa. It's essentially the entire northern hemisphere is just one big glacier. It's pretty much what happens. So if we look, the orbits are still stable, but there's no heat. No heat from the sun means everything gets really, really cold. What's going on with Mars? No ice, because I guess Mars doesn't have a whole lot of, doesn't have a thick enough atmosphere to keep, you know, enough water to make ice out of. Alright, so now here comes the point where we're gonna add some mass to this. Let's make it, let's pause it. Let's make it 20 suns. Let's see what happens there. Alright. And we'll speed it up a bit. Instantly, all the planets just take a perpendicular orthogonal trajectory right towards it. Look, we got all the dwarf planets in minor bodies coming towards it, going on highly elliptical orbits. Very interesting. And now what happens if I introduce a sun to it? Let's see what happens. So put the sun right here, and we'll do an orbit. At 1 AU, astronomical unit, that's 1 Earth distance from the sun, is, oh, and here comes Jupiter, about to whip around, right into the sun. Oh, man. Nope. That was a near miss. Now let's see. That wasn't as interesting as I wanted it to be. So what we're going to do is we're going to increase the sun's mass to make it a black hole. How about that? Let's see. 2 times? Oh yeah. Instantly disrupts all the orbits when we make the sun twice as massive. Okay, so we're gonna pause it. Let's go ahead and pause it. And when we pause it, it allows us to make changes. Let's see. Interesting. Look at that. So if we increase its mass, the sun's mass, by an order of magnitude, that is going to make it go supernova. And my computer's having a hard time figuring out what to do when it's paused. So let's go ahead and that is a weird sound. I think someone's mowing the yard outside, but it's funneling through this kind of hallway feature my parents have on the side of their house there. So it kind of sounds like we're going through a black hole. Let's hit play. Okay, there we go. Instantly. Look at that. I guess the force of it just blew out all the planets on an opposite perpendicular orthogonal trajectory from towards it, just away from it. I mean, look at that. Earth, I wonder if Earth even has a core left over. I guess. Oh, I mean, wow, look at that. Or is that the asteroid belt? Yeah. I don't know if that's... Jupiter just got really, really hot. I don't know if that ring of objects was the asteroid belt pre-existing, or all the inner terrestrial rocky planets blown up there. I'm not really sure. It's really strange. Alright, so what does this look like? Supernova remnant. This thing is 1.3 suns, because I guess it blew off pretty much 9 solar masses. And it's roughly 700,000 kilometers across, or in radius. So that's roughly about what it started out as. See if I increase it by 10 again. See what happens. Interesting. And again. So nothing's happening. Now it's 130 suns. So this is an exponential or logarithmic increase. We're increasing it by, every time we increase it by an order, or by 10, it's called an order of magnitude, which means you're just tacking on another 0 to it. So now it's 100,000 suns, 99,404 suns. And what that means is that we're getting very close to a black hole, and there we go. It just became a black hole. That's so cool. Alright, we don't need labels. Labels are no fun. Let's get rid of the selection circles. Those don't look cool either. And alright. So we have a black hole now that is almost a million solar masses. So yeah, we had 100,000 suns worth of a black hole, and we increased it by an order of magnitude times 10. Beautiful. God, it's so beautiful. I took the labels off. I'm not really sure why it's still labeled. No, that's probably because I had it selected. That's what it was. Man. So beautiful. I have to hit the button down here to make that go away. And that's our thumbnail. I love it. So now let's add... Oh, shoot, I got a date with Molly. I gotta get going, guys. Let me add... Taking her out to get some seafood. I was trying to get her to go see the new Aladdin, or that movie... Late Night, I think it's called. But Molly is... You know, she always wakes up at the crack of dawn, so it's like 6 p.m. right now. It's at a sun right here while I'm chatting about... Yeah, what was I thinking? That was way too close for anything interesting to happen. Oh, yeah, even that was. Molly has an aversion to movie theaters because she, unless it's a movie she really, really wants to see, she's just generally too tired to go see it, so. And there we go. Alright, now my computer is really, really slowing down, I believe. So yeah, I'll update you guys, let you know if me and Molly made it to a movie. But if not, we're going to a little crab shack right on the water near Stewart Inlet. It's gonna be nice. Let's put big old Rigel right here. Or Beetlejuice. How about Beetlejuice? There we go. Alright. Well, not nearly as interesting as I thought it would be, but it's kind of cool to be able to see that, you know, the black hole is able to stabilize the orbits, maintain the orbits of our solar system, and just makes everything extremely cold. So it's interesting that gravitationally it's the same thing as having a sun of the exact same mass, but of course our sun produces the light-giving heat that the plants and animals, and of course we, rely on to survive. No wonder it is worshipped by many of the ancient cults. Is that the sun? Oh. Look at that. These guys were flung out into space. They do such a good job of the graphics of watching a stellar explosion evolve. You could see it just interacting with itself there. I think it's pretty cool. Very interesting. Well, I hope that was somewhat interesting for you guys. I'll try to plan something a little more eventful out next time. I mean, this was quite a big explosion, but maybe I could slow it down. Yeah. All right. Maybe I'll pause it here and maybe we'll pick it up in a little bit. Maybe I'll make a part 2 out of this. Hope you liked it, guys. Once again, thanks for all your support. I'm really glad you guys enjoy these because this game for me is a lot of fun. It's a lot of fun to play around with. So thanks for joining. I hope this was somewhat relaxing, entertaining, informative. Alright, well, I look forward to seeing you guys next time, and we'll continue the Universe Sandbox experience, because this game is too much fun, and there is way much more yet to be explored in this game. So, until next time, sleep well, take care, guys. See you then. Bye.